Good morning. We will start SolidWorks session. Today I'm going to look at the sweep feature and the lock feature. So previous classes we have looked at the extrusion tool and the revolve tool. So these are the other main concepts we have in SolidWorks. One is called sweep and the other one is called lock. So after you finish this lesson, you will be able to do a lot of SolidWorks designs easily. So we will start the sweep tool. I will start from a new file. So the idea of sweep tool is we have a sketch, we have a path, and we have a profile. So we can drive the profile along the path in sweep tool. So we will start with the new file and draw these things and see how it works. Actually, I have shown you this one when I discussed the plane tools, uh, but I will refresh. Now, uh, we have to first draw the path. So I will use the spline tool and I'll start drawing a path. You can use these spline tools. I haven't discussed heavily about these tools, but it's similar to arc tool, so you can draw splines as you wish like this. This is one of the ways of drawing a spline, and press the escape key. And there's another spline called style spline. Uh, this is the normal spline, this is the style spline. So if I draw this one, you can see the control points are somewhere here, so you can change it easily. So you can use any spline tool to draw these shapes. So for my example, I will use the normal one, this one. So after I finish this, I have to exit from SolidWorks. Now I have drawn the path. Now next step is I have to draw the profile here. So I have told you how to draw the planes for a point. So we can use the plane tool here and select the point here and the spline. So when I select these two, point and the spline, I have drawn the plane perpendicular to this point. So you have to make sure that the plane is perpendicular or else 90 degrees to this point. So we have drawn that. Then on top of the plane, we have to draw our profile. So we have to go to this plane and enable the sketch mode. Now, if I want, I can turn it to 90 degrees, or you can draw here. So if I try to draw, say, center rectangle, no need to have the center here. We can draw somewhere here even, no problem. So we can draw here in the center of the point or somewhere here also. So I have drawn it. Now I have to exit. So we have to have two sketches separately, one for the path, one for the profile. And I have the plane here. So now we can start the sweep tool. So we need to have the path and the profile. And now we will start the sweep tool. So the tool is here. So here in the sweep tool, there are two ways of doing the sweep tool: sketch profile or circular profile. So I have drawn this profile. So I am not using the second option. I'm using the first option. I have drawn the profile. So we can select the profile and the path. So this will generate the sweep output. So this is the output I am getting. So we will discuss about these options in a little while. And now if I press OK, this is my output. So this is called sweep in SolidWorks. In a lot of software they say sweep. So you have to have two independent sketches and the sweep. So if I delete this one, I'll get back the two sketches. Now, if I select this again, and if you want to have a thin feature, that is, if you want to have a hollow tube here, you have to enable the thin feature. So when I enable the thin feature, I will get a thin feature can be this side or the other side, or you can change the mid plane to mid plane option or two direction option. So we have discussed these things earlier on the sweep extrusion tool. So we will get a hollow tube, something like this. So this tool is really important in terms of modeling. So any questions, let me know before we proceed. So we have drawn two sketches and we have enabled the sweep tool. So we can generate a sweep like this, or else we can generate sweeps parallel to the path also. So you don't need to draw the profile exactly on the path. You can have some offset and generate the sweep tool. So I will show that here. Now I have drawn the profile exactly in the middle, so we will edit that. For the time being, I will delete this. So we can draw it somewhere offset to this. So you don't need to draw it exactly here. So I have drawn it off at an offset. Then we can run the sweep tool. Okay. So you can see the parallel profile has been created. So this is okay. So you can, what is the usage of this? You can use an parallel path and generate a sweep profile. So that is the usage of this. So you don't need to draw it exactly on the path. This offset is also going to work. So what happens if I change these sizes? Now when I have a big size like this one, sometimes the sweep tool will fail. Now here also it's experience in some versions of SolidWorks the sweep tool may fail. So because he cannot take these bends correctly, so I will enlarge it. We try to get a fail situation. Now it says sweep operation failed to complete. So the basic idea here is my profile is really big. So when my profile is really big, I can't take these bends smoothly. So otherwise, if the bends are very sharp, you cannot generate the sweep tool. So make sure you have a smooth bend and small profile compared to the bends. So you have to have a smooth transition in these curve areas. So that's what happens here. So when you have a big profile, sweep tool will fail. So sometimes this may work. So this is working. Here also there are issues. So these are not really good outputs. So you can remember that limitations in sweep tool. Now I will take some part files. So here also they have drawn the sweep. So the idea here is the path is a closed path. Profile is anyway a closed profile. So the path is also closed. Earlier the path is an open path. Now this is a closed path. So when I enable the sweep tool, apply the sweep tool. it will quickly generate me a closed loop. So remember that you cannot have an open profile. So if I try to have an open profile, this will fail. So for an example, if I come here and delete this area, I delete this line. Now this becomes an open loop. Now when I try to apply sweep tool, he's asking me these options now. This is a open loop. So if I press OK, a profile and a path must be provided to define the sweep. The profile may have more than one contour profile for solid sweep. To make the solid sweep, all the contours must also be closed. Sketch for profile and path cannot be pure construction domain. So here they are giving a lot of messages saying that this is an open thing, open loop. You cannot generate a solid sweep. But if you want, you can generate a thin sweep, but it's not available here. So the thin sweeps are available in surface modeling. So I am not going to touch this area. So surface modeling has this uh, thin sweep. So for the surface modeling, this is going to work. Now, if I show you the surface modeling techniques similar to the solid modeling, profile is here, path is here. He is not giving any warnings. You can see it's generated. So I'm getting that surface tool. So it's inside is hollow. So under surface tools, it will work, but not for solid sweeps. So we are not going to learn this, but all the tools are more similar to these solid tools. These tools have much more flexibility than solid tools. Solid tools may not have flexible options. These have flexible options like we have 3 knitting modes, we have trimming, 3D trimming. So we don't have 3D trimming in solid tools. Surface tools we have these nice advanced options. So if you are trying to generate some very complex shapes, better you go with the surface tools. So we are not doing this in our syllabus. Please remember the sweep tool profile should be a closed loop. Then what are the options we have in sweep? So I will open this drawing and show you what are the options we have. I'm going to open a 7, 10, 18. We will apply the sweep tool. So you can see this output generates. But if I look at my slides, I have two ways of generating this output. One is this one, and the other one is this output. So this is called follow path option. It will take the curve, the face here will bend with the path. So it will nicely take the turn. Here it says keep normal constant. That is, it will not take this surface will not take the bend as this one. So it will keep that original direction uh, unchanged. So if you now this is the output of uh, follow path. So but if you try to take this one as keep normal constant under this option profile orientations, he will keep that original direction as it is. Now you can see the changes happening. This will take the bend and this will not take the bend. It will keep that original direction. Original direction is heading this way. So this is also heading this way. This is the normal vector. So the normal vector is heading the same way. So if I just press OK, you can see the output. Both these faces are heading the same direction. But if I come here and change it to follow path, it will take the bend. So that's the difference between the follow path and the keep normal constant. So depending on the application, you need to use the correct output. Just try it and see. Now the next option is immediately you can see we have a profile and a path, and we can generate two outputs. One output is it's not a good finish output, just generating a sweep code. Here the surfaces are finished and it says align with the end faces. So align with the end faces option is enabled. Here align faces checkbox is clear. So this is not aligned, this is aligned. So we'll see how it works. I'll take 10, 12. So when you do these sketches, you have to make sure your path is coming and fitting nicely onto this edge, coincide with this edge. So this path is coincide here. So these are the two important points. Otherwise, it will not align automatically. So I will show you what happens. So we will enable sweep to get the path, get the profile, get the path. This is the normal output. This is the normal output without align. So if I come here and select the option called align, we have this one, align with 10 faces. Enable that. Automatically it will align with the end faces. So we'll get this out. So I don't need to use the cutting tools and other tools and try to align this. So that's the usefulness of this. But if you draw the sketch, if you draw the path in your own manner, so suppose you come and remove this coincident option and take this path a little bit inside here, you'll see it's not working. It's not working. So it's finishing here. So you have to make sure when you draw the path, this point should come and coincide with this kind of an edge. So then only it works. So that's the rule here. So otherwise this align tool is not going to work. This is not going to work. So this is just a tick of a button. It's taking your coincident relation here. Otherwise it will not work. So you can try this and see. Any questions, let me know. This is similar to our Very sketch tool. So in the Very sketch also we had this tick here. So these ticks are really crucial. We need to understand how these are working. Otherwise, you cannot generate these kind of outputs. Now let's look at how to apply a twist in the sweep feature. For an example, we can generate something like this from the sweep tool. So I will show you how this works. We will take the previous model. This one we can take 1018. So I'm going to apply the sweep tool. So if I want to have a twist option, we have to go to the second areas here. So we have discussed what is the meaning of these two, and we will now look at the twist option. So I will just take the second option, specify twist value. So you can give say the number of revolutions or radians or degrees. So if I want to turn 360 degrees, this is my output. So you can turn either side, and we will get something like this. Really easy. So you can get something like a twisted bar from the sweep tool easily. So what happens when I change this to normal, keep normal constant? Your end faces are going to be in the same direction and your output going to be changed. So this is the keep normal constant option. You can see the bend twisting is not really nicely happening here. So if I have two turns or 720 degrees, you can see how it works. Okay. So this is the keep normal tool, and follow path tool is nicely taking the bend and twisting. So you can try this thing and tell me if you have any questions. So always try. I'm giving time to try the things and check. So if you have any questions, let me know. That's how we can learn the tools easily. Now we are going to move to advanced areas. Now, if I want to get complex shapes without the, I can have additional guide curves. Now this is a guide curve. So if you want to, if I have the profile and I have the path, but if I want more additional uh, support, I can draw these guide curves. For an example, here we have the profile, we have the path, and we have these additional guide curves. So additional guide curves will enable us to shape the 3D model easily. So we will see how it works from an example. I will take the simple example first, 1021. Now this is like an extrusion. Now this path is perpendicular to the profile. So if you uh, just click here, it's like extruded bar. But here we have these guided curves options. We can use this as the guide curve. So what happens? Our 3D model will go along with that guide curve. So we can easily generate a complex shape. So we have the profile, we have the path, and we have the guide. So what happens when I interchange this? Say sketch is same. If I change this as the path, my profile is going to be this. But if I select the guide curve this side, you can see the bend comes and stopping here. So we don't need this additional line here. So it depends on how you choose the tools. So if I just select this as the path, and nicely it's finishing here when you use the guide tool. So other way it's not going to work. It's working, but it's not finishing nicely. So you can see with the turn how it finishes. So this may be extra line. So when you press OK, you will not see that extra line. So you can get this kind of output. So we can draw as much as we like. So if I draw this kind of a diagram, so how can I draw these kind of things? We have to have planes. So nice. Now in this one, they have nicely used these original planes to draw the guide curves also. So we have the sketch, we have the path, we have two guide curves. So I'll enable this sweep tool and show you how it works. This is the sketch, this is the path. We are getting something like a deep shape, and under guide curves, we can use this first guide curve. So once you select this first guide curve, the other side is automatically going to be symmetric. So that's going to happen automatically. And we have this guide curve also. So I have used both guide curves. And here there is an option called smooth spaces. Now when I press OK, the transitions are smooth. You can nicely get this bottle shape in few minutes. But if I have untick this, what happens? You will get a rough surface. You will not get a smooth transition. You may see these kind of contours. So I hope you understood what is the difference between the smooth and the rough one. For an example, if I want to generate a bottle kind of a shape, inside of the bottle is hollow. So we have to use the thin tool, and we can use the normal settings. Now thin tool is enabled, and we go to guide curves and select these two guide curves. And it's a smooth transition. Okay, you can get a thin shape, but everything is now hollow. Otherwise, you get a solid tool working and apply the shell tool at the end, then you can get exactly bottle shape. So you can try these examples and see any questions, let me know. So we haven't discussed how to draw these additional guide curves. So we can draw using the spline tools, or else there are techniques here available called curve tools. So we will discuss this in this chapter after a little while. So how can I draw these complex shapes in SolidWorks? So we will discuss these things also in a while. For the time being, you use the examples given in the given by me and see whether you are okay with the tools. So I use this example. Uh, this example. So we use this example. Any questions up to this basic sweep tool? So we have started with uh, drawing the profile and the path. And I said that profile can be offset to the path. Then we said the path can be closed, but definitely the profile should be closed in solid sweeps. But if you use the uh, surface modeling techniques, this can be open profile also. Then we have discussed the creep normal and follow path options. Then merging align surfaces. Then twisting, these kind of applications. Then guide curves and thin sweep also we have discussed. So we will now look at how to remove material from sweep tool. So I will draw this shape and show you how it works. So we'll start from the beginning. So I hope you can also draw these kind of things now easily. We'll draw this one from the beginning and show you how it works. Now I have to draw the path and the profile. So you can easily draw the path. Normally in SolidWorks we draw the path first. So we will start this, and I will use the line tool here and draw that path. You can use this line tool and get the arc also from the same tool. So here I made a mistake. So this is my path. Then we can draw a profile here. I will use this arc tool, center point arc. Make sure you close this because we need to have a close profile. Two sketches have been drawn. Now we can use these two sketches and apply the sweep. So I'm going to apply not the normal sweep. We are going to apply swept cut. So we have to remove material from here. So I'm going to use the swept cut tool and select this sketch and this part. So okay. So this is my output. So you can see quickly I can generate a swept cut. You can try this and see. Any questions, let me know. Now I have done a small change to this shape here. I have put it into the other side using the mirror tool. So we just use the normal sweep tool again. Here we have another tool called circular profiles. So in circular profiles, actually I don't need to draw this profile. So if I delete this, so I don't need to draw a profile here in circular option. So I need only the path. So if I select this method, we need to give only the path. So you can see we need to give only the circle diameter. So quickly we can get a circular profile like this. So since we are merging the results, there is no problem. So we are merging. The merge options are there. So we don't need to worry. So I hope you understood. So sketch profile, you need to have the sketch here. So if I'm drawing the pipelines, tubes, circular tubes, you don't need to draw the profile. You just select the second option and give the profile diameter. It will quickly get it. So we are merging the results, then there will be no issues. If you unmerge the results, you get something like this kind of output. So you can see materials intersects. Material intersects. You cannot see a perfect boundary line here. And under direct editing also, I can use these now Boolean tools. If you like, you can use these Boolean tools. Say if I want to get the common interfaces, these are two bodies now. This is the common interface. So Boolean tools now working. So since I unmerge the results. So this is subtracting. This may be the main body. This is the target body. This is the subtracting. So same things can be achieved from Boolean also. So all these works because of this unmerged tool. So if you merge it, there will be issues. So this combined tool will fail. So I hope you understood the meaning of the merge tool and the meaning of this circular profile method. So this was a new addition. In all SolidWorks, we didn't have this. So we have to draw the circle. So they have reduced our time having provided this option also. And under cuts, we had another option called solid features. Now, if you don't need to use these booleans and other things, we can use that tool also. So for an example, this model. So this is a solid revolve model. If you look at this one, they haven't merged this. So this is an unmerged result. So meaning here is we have two bodies now. So since we have unmerged it, we have two bodies now. So this may be the sweep cut. So they have applied the cut sweep and we'll delete that. So this is the situation right now. So I can unhide this part. So this is the situation. So you have the extruded cuboid, you have the revolve tool, and you have a sketch path. So I have this body and I can use this body to cut the path. So without using the Boolean operations, we can directly use swept cut and go to the last method, solid profiles. So this should be a separate body. Solid body, it's a separate body. And you have the path. So you have the perfect body, solid body, and the path. Then you press OK. It takes some time. Then after some time, it will cut the material. So this is the output. So you can draw the profile and cut it, or you can use another solid body and cut it. So that's the meaning here. So we have the solid body cutting, we have the circular cutting, we have the sketch cutting. So I hope you understood all these techniques. Just take your time and just do these things and see any questions. Let me know. So I will do a tutorial with you now. I'm going to look at the first tutorial in chapter 10. So we will look at how to draw this in SolidWorks. Now, if you get this kind of an example, this is time is 45 minutes. So within 45 minutes, you will be able to do this. So this is the 3D output I am expecting. So immediately you have to notice that this uses the sweep tool. So because the path is, this is a bend, so you cannot take it from extrusion, you cannot take it from rim. So straight away you need to understand what to draw first. So normally we don't need to draw these flanges first. We can draw the base feature. So you have to understand what is the base here, foundation. Foundation is this middle tube. So we need to start with this middle tube and draw this flange. So you can draw one flange and get a copy here. So no need to draw twice. So we will look at how to draw, get a copy also. We have done this theory last week. And we have a small tube here also connecting to the main tube. So when we get this kind of drawing, better we start with the base feature, the sweep tube. So the path should be drawn and this tube profile should be drawn. Since this is a circular tube, I don't need to draw the circular profile. We can use that option available in Solid. So this is how it should work. So we have to start with this one and generate this kind of output. So I will put it in this one, this slide. So this is not a circle. It's a part, only a part of the circle, and you have two straight lines. So origin is here. So we will look at, if you look at this diagram, this is 90, radius 90, and we have this from here to here it's 60, from here to here it's 55. So we can get these calculations and get these values. So we will start with the model. So I will just use the front plane. Origin is here. So we can start with drawing a circle, semicircle. So we can use the R2 and it's 90. and we have straight lines here. 55, 60. So this is fully defined. Now we can start the sweep tool. So the diameter is given here. Diameter is 65. So this circular tube has 65 diameter, and it's a hollow tube. So 65. Sorry, inside is 65, outside is 97. So this is, if you project this line, it's showing the inside diameter. Inside diameter is 65, outside diameter is 97. So if you want, you can draw two profiles, or else we can use the circular option here and get this working. So we'll select the path, and the outer one is, the diameter is 97, and we have to enable the thin tool. So we can measure inside. So the value here will be 97 minus 65, that is 32. So 32, and 32 divided by 2 is 16. So it should be measured inside this. So I hope you understood. This is the outer diameter of the profile. Uh, we have to reduce 32, then you will get 65. So you can easily get it without drawing the profile. So if you want to double check your values, go to this evaluate tool here, and there are measuring tools available. You can measure it from this one, 97. Uh, this is 65. So correct. So save your model. You can try the other parts. My machine got stuck a little bit. So try the other parts. Try to draw this plant. Now, now the next option is to draw this plant. So the plant diameter is given as 225, and we have a thickness here 25. So I can easily draw this one. Uh, Shake the pen as this surface. So the diameter is 225 at the center, and the thickness is 25. It's going inside. It's now we can draw these holes here. Uh, there are circles here and the middle hole. So the middle hole is also 65 diameter, same diameter. So I can cut that also. So if you want, you can get that from the previous sketch even. So when I draw this post extrude, I can have two lines and get the middle hollow automatically. So this is going to be 65. So from the same extrusion, I can get it without cutting. Then we have these small holes. So the bread circle diameter is given as 185. Circle diameter is 20.5. So we get that. You want to make a vertical sketch to the screen. Then we can easily draw this line, this circle, or these horizontal vertical circles. So we have to just draw the bread circle here. So we will do it now. This is for construction work, and its diameter is 185. Done. Then we draw the circles. We can draw it on the quadrant exactly. This is 20.5 diameter. That's it. Then we can cut it. I'll use the next option, up to next option. Okay. So I didn't use the 2D patterns. My target is to use the 3D patterns. So we can use the 3D tools here, 3D circular tools. Cut. I'm going to have cuts. So the center axis is this one. Features to cut is this cut extrusion. We have 8 holes. Quickly we can get something like this. So are you okay up to this point? So just draw it and see any questions, let me know. Okay, we'll continue the lesson. Now we have to draw the other plans here this side also. One way is you can repeat the thing you did earlier. So it can repeat. But if you try to copy it, we can use the copy tool. So you can't have a circular pattern for because this area is not a circular area. Otherwise, you may be using the circular pattern tools for this plant, but we can't use it here. So if you just look at our extrusion done here, if you unmerge the results, there will be no harm. So this body is not going to merge with the other one, but there are errors popping up here. The internal cut does not intersect the model, so better we have it merge. So how can I get a copy here? Last week we discussed this direct editing tools. Last week we discussed this direct editing tools. So we have this move copy body tool. So we try to use this tool now, move copy. Sorry, we can't use this tool because this is not a separate body, this is a single body. So if I unmerge this one, this can be a separate body, but I got some errors here. So without using those move copy tools, we can use what? We can just press the control key and drag this feature here and put it here. So we have used this one last week. Drag and drop is using the control tool. Just press it here, put it here, and delete the relations. So we will do it again and see. So I have to copy these three, press the control key and put it here. Delete the relations. So you can see how it came, but it's not aligned. So it didn't get these holes also. So some of the features will not copy. Then what we can do is we can easily come here and place this circle center exactly on the center here and exit. So we just did a drag and drop copy without using the body tools because this is a single body anyway. So if I want, I can try this cut even. So this pattern. So we try that also. Put it here. It's not working. So you can see it's not coming here. But this single cut is coming. We will just put it here. So there are errors popping up. So single cut is also not coming. So we got only this base branch. So I will do it again and show you how it works. You can select these features, all the features, and press the control key and try to drop it here. You have to delete the relations. Some of the features also going to be deleted. Now this is not aligned. We can come here to the sketch here and click on the center point and try to get the center by going through this circumference and get the center snap here and press OK. So this is how we use the copy tool in SolidWorks. Otherwise, you could have used this move tool, body tool. Since this is merged, I cannot use that. When I unmerge it, I got some issues. So that's why I didn't use that move tool. So we will repeat the same process for these holes. So we have a construction circle. Its diameter is 185, 20.5. So you can any questions up to this point? Then next thing is we need to draw this small tube connected to the main tube. So to draw this tube, I can't start from this end. Anyway, we have to start from a plane, offsetted plane, 240 to this plane. So we will do that. So we have to get an offset plane 240 millimeters away from this selected plane. 240 millimeters. So this is 240. So from this on plane we can have a sketch. So we will now turn it again. So now we have to draw this tube here. From the top it's 175. The tube diameter is 50, and you have a hole here also. So I can draw 50 diameter tube, 175 away from the top. And 175 from the top, and diameter 50. And here, from here it's 240. So I made a small mistake when I put this one. It should be measured our other side. 25 should be other side. So that's why my this hole is coming a little bit down here. So you have to be careful. So this should be measured other side. So this extrusion should be measured in the other side. So this way. So from here we have to measure. So 175 from top. Now we can ask up to next. Yeah, I have a side tissue in my drawing, so it's coming like this way. So there are some measurement errors. I think I have done a mistake in this thickness here. So this should be outward. So that's what happened here. On all these sketches, this should be measured outward. Uh, you have to be very careful when you get these directions. All these are failing. So we have learned these tools last week, how to edit the sketch planes and rectify the problems if you have. So just make sure you rectify those issues. I haven't. Diameter 175. Now it's okay. Next. So I made a mistake of measuring this side, this one. This is going outside this sketch. So you have to have two flanges outside the lines. That is, flange should start from here, and the top flange should start from here and go upward. So I took it downward and this side. So that's why I got the problem here. So you should be able to rectify these issues if you have made a mistake in the previous steps. Don't try to draw all the things from the beginning. That is not. That's why that is not usually happening in SolidWorks. So you have to always edit your sketches and rectify your problems. Then we have a small hole here, which is 24 up to 28 millimeters. So we can drill that. At the center. This is 24 up to 28 millimeters. Then that hole continues as a small hole again, 20 millimeters up to this point. So it's going through all 20 millimeters. So this can be again selected as the working plane. And inside this one, I have to draw another small hole, 20 millimeters. And it will continue up to next surface. This. So you can see how it has been done. Uh, that's all. So any questions, let me know. So your assignment is mostly based on the sweep tool. So last time I showed it, still I'm preparing that. Uh, so I have to apply the simulation tools also. So you will be asked to use the sweep tools now. These are the sketches we have given. So the sweep tool and the revolve tools should be used. And we have some cuts here. Then this day will take some time. So cuts and other shapes. Then we have